Welcome everyone to this epic webinar, Decarbonisation and Electrification, Are They Really Quieter? I'm Ellie Savage, I'm a Policy Officer at the Institution of Environmental Sciences. This webinar will explore the noise generation implications of increased electric vehicle usage, renewable energy sources, air source heat pumps, and the opportunities to integrate acoustics into zero carbon design. I'm delighted to be joined by acoustics consultant Colin O'Connor. Colin joined Cundall Consultancy in 2021 and leads their London acoustics team with a focus on how acoustics can complement sustainability, health and well-being, and net zero carbon pathways. He has over 15 years experience, primarily focused on environmental acoustics, and provides consultancy on a range of sectors, including workplaces, energy, data centres, life sciences, and infrastructure. Colin has previously held advisory roles to the Thames Tideway Tunnel and Heathrow expansion projects. He is a full member of the Institute of Acoustics and the Institution of Environmental Sciences, an incorporated engineer and chartered environmentalist, and graduated in 2006 with a bachelor's degree in acoustical engineering from the Institute of Sound and Vibration Research, University of Southampton. As always, there'll be a chance for questions at the end of the presentation, so please do submit these in the Q&A option at the bottom of your screen any point during the presentation, and I will ask those later on your behalf. So yeah, thanks everyone for logging in, and I'll hand over now to Colin.
Thanks for the lovely introduction, Ellie, and thanks to the IES for hosting this one today. So yeah, decarbonisation and electrification, are they really quieter? It's just a caveat from the beginning. Most of the thoughts and opinions and views on this are kind of just my own personal ones and ones I've garnered over the years. They don't necessarily represent that of the Cundall or the IOA or the IES or the ANC, who I all kind of sit with. But yeah, I'll take it from there. So just to run over the topics of discussion today, essentially, yeah, decarbonisation and electrification, they are hailed as crucial steps towards a sustainable future with promises for cleaner energy and reductions in carbon emissions. But, you know, this does not inherently lead to quieter environments. They do, of course, offer numerous environmental benefits, such as mitigating climate change and improving air quality, but their impacts on noise are more nuanced. So for today's webinar, I'm going to look at these aspects of noise generation associated with low carbon transition. So EVs, renewable energy, air source heat pump, and also a bit on data centers towards the end as well. So introductions wise, just to introduce myself, I've been working in acoustics for 15 plus years now, studied acoustics at uni, started back in 2003, but before then, pretty much from secondary school onwards, I've always had an interest in science, environment, music as well. So that's kind of summed together to bring me where I am today, working in acoustics. So just a handful of energy and environment focused projects I've worked on over the years. So the Glyn-Ronwy pump storage scheme, noise assessments to support the DCO application, Seneca Energy Farm, noise surveys and assessments for another DCO application. I carried out noise assessments, surveys during COVID for onshore infrastructure associated with the Arklow Bank Wind Park off the coast of Ireland. And also recently, thought adding in this one, Tideway London, given that they've just recently fully commissioned the entire tunnel line. So quite happy with that one, to see that one progressed. So I'm not going to make this presentation too overtly technical. I think it's good from considering the audience we have today, try to get a good spread on the topic. But but thematically, why is acoustics important? I mean, from an evolutionary viewpoint, hearing is one of our key survival mechanisms. It's one of our few senses that never turns off. It's always in play, even when we sleep, and essentially allows us to listen out for danger, even when we are sleeping. Leading up to today, with a lot of research and guidance, primarily from the World Health Organization, but also through 2022, 23, the Science and Technology Committee presented to the House of Lords. So the position we're in now is, we know that noise pollution remains a significant public health and economic burden that needs urgent attention. The House of Lords Science and Technology Committee's inquiry found that 130,000 healthy life years were lost in the UK because of noise pollution in 2018, and that 40% of the population remains exposed to harmful noise levels from traffic pollution. And furthermore, just a few extra points of why acoustics is important. So yeah, health and well-being, so physiological impacts, comfort, concentration, long-term impacts of health and hearing loss, but also numerous legislation and design standards. So the statutory requirements, it's ingrained in planning policy across the UK. There's noise at work, there's building regulations, and also a lot of sustainability and well-being accreditations, such as BREEAM, WELL, and LEED, have large focuses on acoustics as well. So that's kind of where we are. And again, I'm not sure on the makeup of the audience, but just to apologize to anyone, that my main focus of this will be primarily based on UK, maybe a little bit more London-centric focus, just given that's where my career has kind of been held. But more than happy at the end to discuss any thoughts or opinions on how this may apply outside of the region. So yeah, first up, electric vehicles. Can't have an acoustics presentation without a good chart. So vehicle noise components and how they interact to overall noise from traffic vehicles correlates with speed and resultant sound level. So I think probably important here just to break down kind of how traffic noise is produced if we're going to be talking about the transition of the fleet to more electric vehicles. So overall vehicle noise against speed. First, you've got engine propulsion noise. This is the blue hash line you can see kind of zigzagging across. Now it's fairly consistent. It'll change depending on gears, which gear is being used, but generally whatever speed it will be a fairly consistent level of noise. You've got aerodynamic noise, which is the brown dotted line further to the right, but generally that only comes into play and becomes a contributor to overall noise from vehicles at much higher speeds, motorway speeds, 70 miles per hour or so. The key factor of noise contribution and vehicle noise components is tire pavement interaction. So that's essentially the friction of wheels rubbing against the road as they drive across. And that's represented by the red line. You can see that pretty much consistently increasing with speed at a fairly linear rate. Now, depending if it's smaller passenger vehicles, it becomes the dominant source of noise at about 30 miles per hour. And then tire pavement noise becomes for larger trucks, HGVs, and the such at about 50 miles per hour. Now, regarding tire pavement interaction noise, there is a lot of research and development into developing quieter road surfaces. Just bearing in mind that pavements do wear out over time, road surfaces do become louder over their life cycle, but yeah, so there's a lot of research into how that interplays. But with regards to electric vehicles, the issue here, what we have here is that while electric vehicles can be quieter than traditional internal combustion engine vehicles, this is typically at lower speeds. So below about 20 miles per hour or so, engine noise is the dominant factor. So that's where kind of EVs can help reduce noise. So this comes from the tire road interaction and aerodynamic effects only coming into play at higher speeds. So the issue here is the increased use of electric vehicles might not actually greatly affect traffic noise emissions, particularly on higher speed motorways, which are a dominant noise contributor across the world. So there was a good study back in 2012, a conference paper at Internoise, and some researchers took a case study in the Netherlands, looking at in urban environments, what would be the switch if you were to replace the composition of the vehicle fleet, taking away diesel engines and replacing them with electric vehicles. They found in urban situations where traffic speeds are generally a bit lower, you can get about 3 to 4 decibel reductions in urban environments due to changing the fleet composition. Now, what we've got now is this is potentially offset by the need for pedestrian safety and those with visual impairments to introduce artificial engine sounds at lower speeds. In the UK, we've got the Commission Delegated Regulations 2017/1576 that came into play in 2019. And this is a requirement that as of 2019, July 2019, all manufacturers must now install sound generators into quiet electric and hybrid vehicles, particularly when they're reversing or running below 20 kilometers an hour. So something to note here is the sound generated of the artificial sound generated must be similar to that of a conventional engine. And so what we've got here is it's a potential for new sounds and a new soundscape for us to become accustomed to, even if it doesn't actually particularly reduce the overall sound of traffic noise in the end. So what I've got on the next slide, I've got some audio recordings just to kind of just demonstrate the difference. So there's not really a massive level of change in noise, but it's more the soundscape and the context and the type of sound that changes depending whether it's a internal combustion engine car or an electric vehicle car. And then the sound of an electric vehicle passing. So no actual big change in the overall quantum of sound produced, but it's just, yeah, again, it's the sound and the nature of that's changing. So something for us to think about as we move forwards with urban design, soundscape design, and placemaking is what's that change in noise going to be like in the future? Something else to think about with electric vehicles is charging infrastructure. Now, with the proposed changes to permitted development rights that was published in 2024 and the subsequent consultation, superchargers potentially fall within proposed changes to permitted development rights in the UK. And this potentially means sound sources from superchargers. That could be cooling fans and transformer hum from the charger itself, but also any electric vehicle's own fans and compressors when fast charging, such as so that its battery doesn't overheat when charging very quickly. The sound associated with that. From what I can find, there doesn't seem to be that much accurate sound level data for those sort of sources. So there is a potential risk here with permitted development rights, including for superchargers, is you could potentially have these developments occur without a need for detailed acoustic assessment, which can then also be scrutinized by external stakeholders. So this could pose a future noise source with little recourse for post-installation mitigation. Moving on to the next topic, renewable energy. So I mentioned earlier that renewable energy sources, they can produce less operational noise compared to a more traditional fossil fuel energy type plant, but that doesn't mean they're inherently quieter. And I'm going to touch now into a few areas there. So solar power installations, battery energy storage systems, wind turbines, both onshore and offshore, and viewing those. So it's been well over a month since government unveiled their reforms to the UK's energy system with the Clean Power 2030 Action Plan. The 136-page plan outlines the actions that government will take in order to reach its clean energy target. So we're seeing a potential huge build-up of renewables. So up to 50 gigawatts of offshore wind, 29 gigawatts of onshore wind, and also up to 47 gigawatts of solar power. And this is all aimed at significantly reducing our fossil fuel dependency. So me, as an acoustics person, my first question is, what does this mean for noise? What does this mean for acoustics? So looking at solar farms, which are often accompanied by battery energy storage systems. I'm just going to cut that down to BESS, refer to BESS from now on. So yeah, solar power installations, they involve the use of equipment such as inverters, substations, BESS, and associated cooling systems for the batteries there. So you've got economies of scale to think about. Commercial utility scale projects typically start at about 200 acres. They are large sites located in quiet rural areas. There is a potential wide dispersion of both construction and operational phase noise impacts. Little myth to dispel about solar farms is they're not quiet. They don't turn off when the sun goes down. You've got substation transformers that where it connects to the grid. Those potentially operate 24 hours a day. Inverters or panels and their motors, if they're not static solar plant, you do often have early starts and late finish, especially during summer months when the sun rises earlier and it sets later as well. Also, battery cooling fans. So where you've got BESS installed, and especially particularly with increased temperatures, especially during the summer, be it daytime or even nighttime, hot summer nights, battery cooling fans can operate 24 hours a day, and also they work harder when it's warmer. So any sort of noise assessment you'd see for BESS ideally should take into account what's the temperature situation and how do the fans operate under those different conditions. Something else I've been thinking about, been ruminating, but I haven't been able to figure out how this should go around is sorry, I skipped a bit. Going back to site context, again, you've got these large plots of development, often in rural areas with lower background sound levels. It's not just human receptors, people live nearby, especially for much larger sites. You've got ecological receptors, equestrian receptors, and other non-human receptors that may need consideration. That would often be the remit of the ecological specialist to look at how that interacts. But also in countryside, rural areas, you have a lot of public rights of way, amenity use around it that needs to be considered. Sorry, and as I jumped forwards earlier, something I've been thinking about is if one is introducing large areas of solar panels, which essentially act as acoustic reflectors, can this also affect how far other sources of sound nearby can propagate? So if you say have an industrial facility to the west of the site and you've got a number of residential units to the east of the site, could potentially having so large swathe of solar panels on the ground increase the amount of sound that can propagate from the industrial facility and cause further effects on those existing residential units. So it kind of ties back to national planning policy, agent of change principles. So it's not really something I've seen considered too much. I thought I had a while ago a conversation I've had with others, but I think it's definitely an item of a little bit of research that needs to be considered if this sort of situation ever pops up. Looking at wind turbines, first up onshore. Now, wind turbines generate noise from blade rotation, gearbox operation, and aerodynamic effects. I'm not going to go so much into the technical details of noise generation, but I thought it'd be good to kind of touch on the kind of history and where we are now with the actual assessment guidance. So technical guidance that's in place to support acoustic practitioners, planners, and decision makers as to the impacts of wind turbines on local communities and receptors. So in 1996, ETSU R97 was published, and this set out the assessment and rating of noise from wind farms. Subsequently, in 2013, the Institute of Acoustics Good Practice Guide to the Application of ETSU was published. Now, since the ETSU guidance was published in '96, the context has changed. So the Department for Business, Energy, and Industrial Strategy commissioned a review of noise guidance from onshore wind farms. So since then, the context changed. The need for onshore wind energy is more urgent. Technology has advanced new research has been undertaken, and also the understanding of wind turbine sound has progressed, highlighting in particular the potential impact of amplitude modulation, so changes in sound levels that can be quite noticeable. In 2024, a tender was put out to commission an actual update to ETSU. And then recently, during questions for Department of Energy Security on Net Zero, part of UK Parliament's written questions, answers, and statements, the question was raised by an MP as to what's the expected timeline for ETSU, for the new ETSU guidance to be published, and the answer from government at the moment is there is an aim to publish this in spring 2025. So hopefully we might be getting some new guidance to refer to quite imminently. Next up, wind turbines, but looking at offshore wind turbines this time. Now, again, like a nice chart, wind farm lifetimes, they typically involve 40 to 50 year commitments. Now, this can include site surveys, construction, operation, and eventual decommissioning. Now, because their areas often overlap with essential fisheries habitats, and as well as marine mammal breeding and feeding locations, there is a need to understand, mitigate, and manage offshore wind farm impacts and ecosystems. Now, activities during all phases of wind farm lifetimes can produce underwater sound, and this is a concern because high noise levels and persistent man-made noise can impact marine life in many ways. So, for certain portions of wind farm development, there is a small amount of available data that allows stakeholders to evaluate the impacts for at least some species. There's also been a lot of development of underwater sound propagation models, which does involve a lot more calculation factors compared to how we normally look at airborne sound. So 2024, the US National Marine Fisheries Service has updated their guidance on assessing the effects of underwater sound on marine mammals. Popper et al., this was published in 2014, that set out the sound exposure guidelines for fishes and sea turtles. There are a number of documents online, kind of industry-led provided sound level data that can be used for assessment of all various marine activities, as well as, again, National Physics Lab and a lot of software developers looking at producing more accurate, more reliable, more validated sound propagation modelings. But ultimately, we are somewhat data deficient for most species populations, life stages, and other phases as they relate to wind farm development. So it is difficult to evaluate impacts with a very high level of certainty. So there is a need for further studies to assess the impacts of offshore wind farms on vulnerable and ecologically and economically important marine species. Touch a bit on air source heat pumps. So decarbonisation plans for building retrofit projects often include air source heat pumps, and ultimately rooftops are usually the preferred location in urban areas. This is due to just the space availability of where to physically put them. And the issue here in the urban areas particularly is they're usually overlooked by lots of noise sensitive receptors. You've also usually got quite stringent noise limits often apply to avoid background creep in already noisy cities. So that's the gradual increase in ambient noise levels by introducing new noise sources. And something to bear in mind as well is commercial scale air source heat pumps. They aren't quiet. They're big pieces of kit that need to operate fairly continuously to serve a building. Mitigation options are somewhat limited. So something to think about from a planning point of view is, are there height and visual restrictions on what you can put, be it barriers, louvers, silencers, and that. Something that flags up a lot is where we are retrofitting buildings is what's the actual structural weight capacity of that building to put new equipment on top of the roof. You might already have a significant tonnage taken up by the air source heat pumps themselves, but is there actual weight capacity for the building to have additional physical mitigation measures placed on top? Selecting quieter plant is often not feasible. It's, there is a mechanical strategy that's in place. And then some other factors to think of as well is, airflow is very important. So, acoustic louvers need putting in place, but you've got open areas that reduces their effectiveness. So quite often the cleanest or easiest thing to mitigate. So something to bear in mind on these sort of things is the earlier an acoustic designer can get involved on these sort of strategies. So, the better ability we have to positively influence the design and kind of design out any acoustic risks. On the flip side, the later you get brought in, the more expensive or the more harder it is to mitigate acoustic risks as well. So the key story here, it's important to get acoustics people involved for early risk, especially in early risk assessments and mitigation strategies where you've got kind of building retrofit projects and large scale, commercial scale air source heat pumps going in. So just to close out on last topic I'll be looking at, it's obviously hot in the news at the moment. So data centers are energy intensive facilities. According to the International Energy Agency, data centers account for around 1 to 1.5% of global energy consumption. And the actual growth of electricity demand for data centers is projected to be rapid. The IEA also pointed to the industry's aggressive investment in renewable energy sources, which ties us back to the various noise issues discussed in the previous slides of where's that energy provision going to come from. So rather than delve into noise emissions from data centers, I thought it worth to delve into a different view on where acoustics interjects into data center design. Now, Cundall's Zero Carbon Design 2030 commitment, it's a global initiative that engages everyone in Cundall. So achieving net zero carbon design on 100% of our projects everywhere in the world by 2030 is a challenging target. I think admittedly, we don't know all the answers, and we do recognize that not every project can achieve net zero carbon today. But, we do see the greatest option for achieving zero carbon as reduction. So this can be a reduction in materials, energy demand, our consumption habits. And to support this, what we have developed are zero carbon design pathways. So we've got an initial design process and engagement with our clients and design teams. We set out the key steps to decarbonizing the building or development, what it may be. And also we set forward proposals that with an aim to achieving the targets, including key initiatives. So on the next slide, I've got an example of a zero carbon pathway focused on where acoustics as a discipline can influence the design in this way. So an example for data center is actually one of the primary ways to achieve carbon reduction in acoustics is by minimizing the upfront embodied carbon, which refers to the carbon emissions generated during the manufacturing, transport, and installation of acoustic products. So in order to support our commitment to achieving net zero carbon, this table highlights some alternative approaches that could be adopted for acoustic material selection and procurement methods. So essentially looking at traditionally MEP consultants will select equipment and the layouts, but our alternative approach is early engagement with an acoustic design to evaluate the selections and layouts. So can we naturally reduce the amount of noise control required, thereby having a more efficient design that can lead to lower carbon? Looking at the actual noise mitigation design, traditionally procurement from common suppliers. Something we'd want to do is can we review and compare the EPDs for different products so we can help source products that have the lowest embodied carbon but still achieve the acoustic performance requirements we're aiming for. And then after that, sourcing from local suppliers, looking at EPDs, again, with an acoustics performance in mind, but, what can we do to assist there? So, and these are the sort of opportunities that we generally suggest with the intention of encouraging the project team to explore and adopt more sustainable construction practices, ultimately advancing towards that goal of net zero carbon. So, 30 minutes on the dot, I think. So conclusions, just some closing thoughts from myself, really. I know it's been a bit of a wide-ranging I haven't delved too much into the technical details of acoustics, but hopefully a lot of topics with regards to decarbonisation and electrification as to where acoustics and noise sits within all of that. So, I mean, ultimately, decarbonisation and electrification, they do offer significant environmental benefits, but they don't guarantee a quieter world. The noise impacts of those depend on lots of different factors, be it planning policy, decisions made on a local, regional, national type level. But as far as I'm concerned, it's essential to consider noise reduction to create healthier and more livable communities. And finally, electrification, it's not necessarily quieter. It just sounds a bit different as well. So soundscapes in mind, placemaking, something to bear in mind for future and where we progress with that. Okay, thank you.
Thanks so much, Colin. Yeah, that was really informative, and I think as the Institution of Environmental Sciences, who we've got members not just working in acoustics, but also in climatology and see a range of fields. We're especially interested in where these kind of different areas of environmental science overlap, and sometimes overlaps to areas where there is actually their intention with each other. And I think net zero and acoustics is a classic one of those uncomfortable areas sometimes within environmental science, but one that needs to be further explored and work out how do we kind of accept the trade-off. So yeah, really interesting. Thanks. We've got a few questions in the Q&A. Still time if you want to put some questions in now. We've got 15 minutes or just under 15 minutes, so please do pop them in. But yeah, to start with, we've had a question from Sonia. Would the road surface and road surface quality impact noise readings, and would also weather be a factor as well?
So, short answer, yes. Yeah, I mean, there's different types of road surfaces that can be used. So I'm not super up to speed on the actual makeup of road surfaces, but I know there's different levels of materials and how it's kind of mixed together that can allow the extra absorption of sound when roads drive past, but also the weather does impact as well. So particularly on rainy days, the additional water on road surfaces can increase overall levels of noise.
Yeah, and I guess that's so, and obviously that's been taken into account when the readings have been.
Yeah, a lot of generally when doing environmental noise measurements where roads are a contributor to the sound source, there are a number of the ISO standards, BS standards will have requirements in there. It's essentially not to carry out noise measurements either during rainy conditions or after rain, just because of the increased level of road traffic noise that may not be representative of the kind of typical noise environment in that time.
Thanks. So yeah, short answer, yes, Sonia. And I'll also, Colin has said it's all right for me to put his email in the chat. So if we don't get around to your question, or if you have follow-up questions, Colin said that you can email him. So I'll pop that in a second. So next question from Thomas Benson. So considering the potential reduction in background noise levels and change in soundscape, do you foresee compliance as a potential issue for industrial/commercial sound source?
Thinking in terms of numerical comparison. Yeah. I mean, yes, yeah. Again, there is a lot more focus now on the noise impacts of industrial commercial sound sources. We've got a lot more understanding now of the health impacts of that. There's a lot more scrutiny now. I think us as a society are becoming not more sensitive, but more aware of noise, how it relates to our kind of health and well-being, our amenity, and particularly from a planning level as well. It's definitely something that gets flagged up. But then looking at soundscapes and kind of the quality of sound produced, I know in Wales they've integrated soundscape, which is the kind of the perceived quality of noise of external noise environments. They've integrated that within Welsh planning policy now for development. So yeah, I do see it as soundscapes and as a more increasing important factor. I think moving away from just the numerical analysis of things, but yeah, certainly the quality and the perceptions of how we take on board sound are definitely becoming more important. There's also ISO 12913, and there's a lot of efforts from that in introducing ways of assessing soundscapes and those kind of quality perception type factors. Nigel Kerr, could or would electronic noise design for EVs be configured to allow better spatial awareness to pedestrians? Yeah, I don't see why not, but I think something to bear in mind is the regulation itself. Well, in the UK at least, it's the requirements there. The onus is on the vehicle manufacturers to produce those sort of sound sources. So yeah, how they could do that there, probably something to look at some more of a psychoacoustics point of view. Okay, going down. Dean Walters, you have a 15-year-old air source heat pump, which is pretty loud. Has technology advanced with quieter models, and do they need to produce manufacturers' noise specs? I think, again, short answer is yes, technology has advanced. I think the air source heat pumps that are available on the market tend to be a little bit quieter. I think, again, noise is quite an overriding factor. You might see it in the news fairly often, air source heat pumps and noise associated with them being quite a hot topic of contention. But again, there are mitigation measures available for those, particularly on the kind of home scale level or air source heat pumps. It's more, having a discussion with the suppliers, with the installers, with an acoustic consultant as well, is to just develop a good quality mitigation scheme for that. Often doesn't need to be too much, maybe an acoustic fence around where the air source heat pump is located, still allowing for sufficient airflow. So, and then in terms of manufactured noise specs, yeah, most of the suppliers will have kind of good quality noise data available. A couple more questions. John McAvoy, are there adverse noise impacts from high voltage electricity transmission projects? Again, yes, and this is something that's flagged up again in the UK in a policy EN1 and some of the other policy statements on energy is a discussion of noise from high voltage lines. So you sometimes get crackling out the line. It depends on the humidity, air conditions as well. So again, yeah, something that needs to be assessed there. From Daniel Valles, do you see the quality availability of manufacturers' noise data to have improved over the years, particularly in terms of the solar and BESS industry that may still be considered emerging? So, good question. I think this is probably something I'd say comes back on myself and others in the acoustics industry as practitioners. I think it's for us to push back onto manufacturers to provide better quality sound level data, both for us to do their assessments, but also us to give feedback as well. Like, when acoustic tests are commissioned, it's, is the data the sort of data that we're after? How's it been measured? What's the quality of the data? What's the measurement distances? How have things been back calculated? Just the quality there. So I think the level of information is getting better. I know when I did my first solar farm assessment, about a good 10 years ago, I think the level of data was close to non-existent, apart from a couple of small examples here and there. But we are seeing much better, manufactured data now. But again, it's the onus is on us as acoustic practitioners to review it, check it, especially during commission testing as well. Is can we get actual in situ measurements, and can we compare that back to the data we've been provided? Ultimately, is it valid or not? And if it's not, or if it is, making sure that's fed back to the manufacturers. Yeah, I think it's probably it. A couple more ones. Paul Houston, possibility of increasing the quietness of tire design. I think there's a lot of research going into that, as how tires are configured to reduce that. Yeah, it's not something I've looked into much, but I am aware there's a lot of research into that from the industry. Couple more. Yeah. Has the fact that home working has become more commonplace Has this introduced a noise issue in your opinion? I mean, it has as well. We found, especially during COVID, while I was at Tideway, you've got huge construction sites that had consented hours for working, but then with a big shift in people suddenly working from home, all of a sudden you've got a lot more receptors that are people who are affected by noise now present during the day, who now have their own noise issues and their ability to work kind of affected there. So yeah, it's definitely changes in receptor positions and the context there. And yeah, so I think this is the last question from Paul Houston. I have to admit, most road traffic noise I get near my house on National Limit Road is the noise when the cat's eyes are driven on. Okay, any new design for those? I'm not aware of those. I think there's always safety considerations with those things. I think, yeah, not sure to be honest. Sorry.
If I could also ask a couple of questions quickly, to kind of finish us off, sneaking at the end there. I guess the presentations touched on a lot of these issues and the tensions, as I was saying, between noise pollution and other areas, well, decarbonisation, electrification. Like if you and touched on some of the solutions or mitigations, but like if you could just pick one that you think, if I was, if you had all the power for a day, that's what you do, and it would be like the most effective kind of thing. What would you pick? So it's a horrible question.
Yeah, maybe not a technical or physical thing, but I think more of a more awareness of
Yeah,
kind of the more awareness of the health impacts of noise. I
yeah,
think it's probably the thing I'd want to raise more awareness of. It's often, often noise is often somewhat low on the ladder. It's low on the hierarchy of, big ticket items and considerations we put forwards. But what I'd really want to see, yeah, again, is just an increased awareness of noise and knowing that while it might not be an immediately physical thing that you can touch or, you know, directly affect you, it does have a lot of consequences. Elevated stress, um, and sleep disturbance, loss of enjoyment and amenity of public spaces and that sort of thing. So I think it's a big rider in kind of the quality of our day-to-day life, and I think it's just an important part of how do we live day in day out, particularly bearing in mind that we can't turn off our hearing. It's always present.
yeah, yeah. Because it's all about all of these things about trade-offs, right? And just getting policymakers to kind of see it as a priority.
Yeah,
That is the key to unlock all of the solutions and at least the mitigations. Um, and yeah, I think the question, like how do we get policymakers both at the national and at local level to take noise more seriously, is a question that we all need to ask ourselves. I think you're right, focusing on the health impacts makes a lot of sense. I mean, it's certainly something we're thinking about at the IES, like, how can we kind of raise awareness of noise pollution, and EPIC's predecessor, Environmental Protection UK, did a lot of work on that, and did the Noise Awareness Week, as some of you might have remembered. And so we are kind of looking at that given EPIC's legacy. But brilliant, we are 1 minute over time. So thanks again for presenting, Colin. And that's it from us today. Thanks everyone for coming. I hope you found it really informative and useful.